What's up, YouTube? So we got one S5 running. We got a second CR10 S5. Pulled it apart, did some troubleshooting. See that in a different video. On the control board, we have one of the stepper drivers, specifically for the extruder, has failed on this board. So what we're going to do is we're going to retrofit this CR10 S5 with a Big Tree Tech Octopus version 1.1 board, and we're going to also use a Raspberry Pi Model 4B with the 2 gigabytes of RAM. So we're going to run Klipper on this, and let's get started. So I've gone ahead and I mounted the Octopus board and the Raspberry Pi on a piece of cardboard. This will just help me move it around, kind of figure out how I want to lay it out. Eventually the printer is going to become standalone, but it's not at the moment, so let's figure out how this is going, and we'll go further forward. So I've already followed Ed's 3D Tech to get Klipper installed on both the Raspberry Pi, so it's running Octopi with Klipper, and we've downloaded the firmware to the Octopus board. So right now we'll just get the stepper motor set up, configured. So we're going to be using the TMC 2209 stepper motor driver. So pulling up the Big Tree Tech Octopus version 1.1 manual. Show a little snapshot of it here on the screen. These stepper drivers run in UART mode. So we've got the pins set up for the first 5. We've already taken out the jumpers. So it's just leaving the first one on the left open. The second one has a jumper, and then the other 2 are removed. This board, it looks like, comes up set up for SPI mode, which is 4 jumpers all across that top row. So we'll go ahead and put these in. And we can follow the red to the red, the black to the black. And there we go. And this board does have 3 more stepper outputs. Maybe at some point this machine will get a second nozzle, but for now it's just 1 extruder and then 2 Z's. So there we go. All right, nice little mess of cables there. My plan is to figure out how I want all the wiring to be done so that in the standalone box that happens, that can all look nicely and be better. And just a note for everybody, this jumper, once you start powering it with main power, you want to remove that so that you don't back power or fry the Raspberry Pi. All right, let's connect our end stops. So the Creality board uses a 2-pin. The Octopus board uses a 3-pin. Because it's just a dumb wire, it doesn't matter which wire goes where, but we are going to want to know, are we using power, ground, or signal? So it goes power, ground, signal, and if we use ground and signal, then we only need 2 on the end. You can take a sharp point, push down on the pin, get it lined up. And you do want to make sure there's a little tab there, so you want to make sure you're getting it pushed down before you start to yank. Otherwise you can pull the pin out of the wire, and then that's no good. There we go. We'll get our connector lined up. clicks right, should just click right in. Bend the tabs up a little bit. There we go. Feels a little backwards, but there we go. And this is our X. So it'll go just like that. And now the Raspberry Pi's up. So we'll be able to connect to it with Octoprint. Connect to the board and turn on power. And now we'll jump over to the computer and we'll be able to see if we can get any signal. All right, so in the process of getting this set up, I have learned some things. One, if this status LED here is blinking pretty quickly, that means that you do not have your firmware installed. So I just figured out how to get the firmware installed. You can reload the bootloader if that might help. The other thing is make sure that this SD card that you have is 8 gigabytes or less. I had one that was 64 gigabytes and it wouldn't load. The other thing is when you configure Klipper on the Raspberry Pi, it is going to call it Klipper.bin. You need to rename that to firmware.bin, with firmware being all lowercase letters. Once you have those two things figured out or done, I guess I had to figure those out. Then you can put them in. You'll see the status light blink, and then as the firmware is loaded and it has firmware, then the light will turn solid red. So then we can come back as we have all of our motors connected and our end stops. And so now you can see through the Klipper terminal, we're able to call M119, and that's gonna tell us that each of the end stops is triggered or not triggered. So it's open right now. And then as we touch each one, we can hold it down and the end stops say triggered and open. So we're good to go there. All right, so I had to change the direction pins for the X and the Y. Now they home correctly, and they home in Z as well. Probably should change these homing speeds. They seem quite fast. Welcome everybody. So coming back, I had to get a 24 volt power supply. So the Octopus board expects 24 volts, but the heated bed is still 12. So we're going to be running 2 power supplies for the moment. In the future, I'll probably update that heated bed to something 24 volts or maybe even 120. So that'll be a whole different thing. That'll be a different video. But today we're going to get both boards hooked up so that we can power the board and the motors, and then power the heated bed with the other power supply. So I started printing this. It's a power supply holder. I accidentally unplugged the printer. That was my own fault. Print stopped, tried to restart it, and it never heated up the end stop, or the thermistor. So print failed, but it still holds the switches nice enough, so it kind of contains the wires. So we'll still use it for the moment. And then in a future video, we'll lay out how all the electronics are going to go in. I want to make sure, because it's all going to lay flat and probably on the outside of an enclosure, that all the wires route nicely and everything's in a good spot. So let's get to it. And something to note, if you check, the plus and minus on bed power is actually switched. So good thing we checked that. Flip that around. Minus plus, minus plus, minus plus, plus minus. And then we'll take our thermistor. And I believe they go in these pins here, but we'll look that up. So I realized I need a 24-volt thermistor for the pot end. So to keep going on this build, we'll just get started. We'll put the BL touch on. We'll just start exploring there. Alright, we'll turn the printer on. Alright, so what I learned with the BL Touch is that you do need the carrot under the sensor port. It's a little pull-up resistor internal to the board, and that'll actually give you the change state. Otherwise, it doesn't work. I just spent about 20 minutes figuring that out. Hopefully that helps somebody.